All right, so I'll just do the ones that were sine and cosine. Skip the tangent. This one was 0. This one was pi over 3. This one was 5 pi over 6. And this one was negative pi over 4. This one was pi over 2. And this one was also pi over 2. Now, I don't know about you, but when I was doing these, I started every problem like this. I needed to visually, that's the way I am. I need to visually see what I'm working with. So every time I looked at these problems, I was like, okay, sine, that's these two. You know what? Cosine, that's these two. And I just started every problem like that because otherwise I have to rethink it every single time. Remember the trick that we talked about? Yes, a trick. Cost, right? If you write the word cost, right? Cosine goes this way, sine goes down, and tangent goes down. So does everybody understand that trick? I kind of threw it at you really quickly at the end, but it's because if you think about the quadrants, cosine goes this way, so we have it written horizontally, and then sine and tangent are this way, so sine and tan we write down. So that's just a way of remembering. So when I approach these problems, that's kind of the first thing I do. You can see that's what I did. I drew a thing every single time because that's just the way I need to do it. And I think that's a good way to do it. Any questions on those? How'd you guys do? Okay, excellent. All right, let's go back to tangent then. And yeah. Oh, thank you. Thank you. Okay, so tangent, you remember, looks like this. It's got the asymptotes at every odd pi over 2, right? So it's 1 pi over 2, 3 pi over 2, 5 pi over 2. That's where all of the asymptotes are going to be. So the period of tangent is just 1 pi as opposed to the period of cosine and sine. So when we restrict the domain of tangent, we just need to use one period of the tangent. And so one period of the tangent is 1 to 1. So we can just restrict this domain right here. Right? That's going to be what we're going to use. And so our restricted quadrants are between negative pi over 2 and pi over 2. So like I said with my trick, right, tangent is just like sine. Sine and tangent both go down. Quadrants 1 and 4. Okay, so again, we could fill in these values. I actually want you to take a second to do that. I know it'll take more than a second. It's good practice. Try to do it without referring to an already printed unit circle. Try to do it without referring to an already printed unit circle, because when you have the test, you are going to be given a blank and you got to fill it in yourself. All right, so try to practice that right now. And once you do that, put the ordered pairs also. Okay, put in the ordered pairs. And then the next step is to find the tangent at every ordered pair. So remember, tangent is sine over cosine. Sine over cosine. So for example, this is pi over 4. The ordered pair is going to be root 2 over 2, comma, root 2 over 2. So when I think tangent, I'm going to think sine over cosine, so that's the y over the x. Well, these are identical, so it's root 2 over 2 over root 2 over 2. Remember, dividing by a fraction is the same thing as multiplying by the reciprocal. So I'm multiplying by 2 over root 2. This is really clear over here. But we should know anyway that if you put the same thing over itself, you just get a tangent of 1, right? So find the tangent at each interval. You can do some work in here if you need some calculating space, and then write the tangent over there. Okay? So tangent at pi over 2, or 90 degrees, what's the tangent? Undefined, right? Because we're at the point 0, 1, and tangent is sine over cosine, or y over x. You're going to do 1 over 0, and you can't have 0 on the denominator of a fraction, so the tangent turns out to be undefined there. For pi over 3, tangent turned out to be, what'd you get? Just root 3. I should be writing theta or something here, but the tangent at this spot, at this angle, is root 3. Here we have tangent of 1. At pi over 6, the tangent turned out to be root 3 over 3, exactly. And then the tangent here turned out to be what? 0. And then since when we're in quadrant 4, everything is pretty much the same reciprocal, the same fractions, but one, the x is positive, the y is negative, so everything here is just going to turn negative of its reflection from quadrant 1. So this is, tangent is negative root 3 over 3. Tangent here is negative 1. Tangent here is negative root 3. And the tangent here is also undefined. Anybody have questions on how we got those? Okay, so if you do that legwork, well, then these become easy. If you don't have that legwork done and you get to a problem like this, like, in the practice that we're about to do, remember that if it's 1, then the numerator and the denominator had to be the same. So you're dealing with something pi over 4, right? In this case, either positive pi over 4 or negative pi over 4. If it's 0, then it has to be the numerator was 0. So we can't have the denominator be 0, right? So the numerator has to be 0. So sine has to be 0. So then that gives you the 0 degrees, right? And then these are the two that you kind of have to figure out, well, which one am I dealing with? Am I dealing with a pi over 6 or am I dealing with a pi over 3? And, it's guess and test a little bit, but if you can think about the fact that something canceled out here, right? Square root of 3 over 2 is one of the x or y values, right? That 2 canceled out. So it probably looked like this when you did the multiplication, right? So sine over cosine, the sine is going to be the negative root 3 over 2, and then the cosine is going to be the 1/2. So if you think about it that way. Okay, so why don't you fill in those 4, and we'll just double check, make sure we all have the same thing. All right, so this one should have been pi over 4. This one should have been negative pi over 3. This one should have been negative pi over 6. And this one should have been 0. You could do 45 degrees, 60 degrees, 30 degrees. All right, so this is a little summary. Remember, the answer to an inverse trig function is an angle in degrees or radians. It's your answer, right? The input, or the x that they're putting in these parentheses here, is going to be between negative 1 and 1. That's it. Yep. Yeah, it's pi over 6. You're right. Sorry. Yep. Thank you. Pi over 6, positive. 3 over 3. Yeah. Okay, and then this is just a summary of, these visuals. Sine is these two. Cosine is these two quadrants. And tangent is the same as sine. And there's our trick again. All right, so any questions on sine or cosine or inverse tangent? All right, so let's go to the section that's marked more inverses. Because this is where they're going to complicate things a little bit. So now we're finding the exact value of the inverse cosine of the sine of 5 pi over 4. Because we weren't having enough fun. We wanted to spice it up a bit. All right, so the thing is, when we are doing these problems, you're really not, you have to look at whether you're finding the regular old sine or cosine, or whether you're finding the inverse. And remember that the regular old sine or cosine doesn't have a restricted domain. But the inverse sine or cosine or tangent has the restricted domain. Okay, so when we're doing this, we're kind of asking ourselves two questions. First, it's just like order of operations. Oh my goodness. I do not know what that just happened, but okay. You want to look at what's inside the parentheses first. What is the sine of 5 pi over 4? What's the sine of 5 pi over 4? So remember, this is not a restricted domain. 5 pi over 4, well, where is that? That's 1, 2, 3, 4, 5 pi over 4, right? 1, 2, 3, 4, 5. That's that spot on the unit circle. What is the sine of that? Well, remember, sine is the y value, so is it positive or negative? Negative, and it's negative root 2 over 2. So, what is the y value at 5 pi over 4? It's negative root 2 over 2. Okay, so clearly we weren't in our restricted quadrants there, but now we have to think about our restricted quadrants, because now we're finding the inverse. So this problem then becomes, what is the inverse cosine of negative root 2 over 2? So now we're thinking restricted domain. Cosine is these two, right? Cosine is the x value. So is it going to be the first quadrant or the second quadrant? Second. So you know you're over here somewhere. And if it's negative square root of 2 over 2, we're going to again be at a fourth, right? You're going to be at a 3 pi over 4. right. So let's do the next one. Find the exact value of the sine of the inverse tan of 1. So now this is the opposite order here. With the first one, we did the inverse of the regular. Here we're doing the regular of the inverse. So now we have to think about that restricted domain first, right? We're finding the inverse tan of 1. Well, inverse tan, I'm thinking these two quadrants. Tangent is a positive. So which quadrant does it have to be in? First. And if it's one whole, that means it was the same thing over the same thing to get that 1. So again, we're dealing with a pi over 4. So now the question becomes, what is the sine of pi over 4? Right, because this turned into a value of pi over 4. So what's the sine of pi over 4? Root 2 over 2. That you're basically taking the inverse sine of the sine of something, right? And you're taking the inverse sine of the sine of something. So that's a little bit of a different situation than the first two, where it was the inverse cos of a sine and then a sine of an inverse tan. They were different things. What should happen if we take the inverse of the thing? You know what I mean? Like if we take x squared and then the inverse of x squared, shouldn't we just be back to x? Right? Because we're taking the square root. The inverse is the square root. So inverses are supposed to undo each other. That's what inverses do. They undo each other. Somebody said, this is like those logs and exponents. Yes, because logs and exponents are inverses of each other. They're supposed to undo each other. So this one, you take the inverse sine of the sine of pi over 2, you should be back to pi over 2. Right? But did this one come out to 5 pi over 4? No. Why? It's not in the quadrants that we restricted for the inverses. So that's why it doesn't quite undo itself there. It's going to be related, right? It's kind of like across the way from each other, but this one came out to negative pi over 4. Okay, so we can kind of summarize by saying, you know, this is just saying the inverses undo each other. In other words, this is like this one, right? The inverse sine of the sine of something just equals that something. If, what does that x have to be between? If it's sine, if it comes within our restrictive negative pi over 2 to pi over 2. Right? If it's in that restricted domain of sine, then the inverses will undo each other. The cosines will undo each other if it's in the restricted domain of cosine. What is the restricted domain of cosine? 0 to pi, right. And the tangents will undo each other if the input is between the restricted quadrants of tangent. So this is just like sine, negative pi over 2 to pi over 2. Does that make sense? So they undo each other if they're in that quadrant, and they don't undo each other if they're not. If they don't undo each other, then they should at least be like reflections of each other. So let's look at number 5. Is pi over 12 1/12 pi? Is that between negative pi over 2 and, between 0 and pi, because it's cosine? Is it between 0 and pi? pi over 12? Yeah, so is it going to undo each other? Yeah, so this one we don't have to give much thought. It's just going to be pi over 12. I'm feeling this test will be pushed off. What do you think? Yeah, because I didn't really even finish teaching it yet, so we probably should have one more day to solidify our brains around it. So Thursday, plan on Thursday, the test, okay? Okay. Let's not get off track, though, because we do have to get through this stuff. All right, so number 6. We're talking about sine, right? And the restricted quadrants of sine are between negative pi over 2, or negative 90, to 90. Is 100 degrees in that? No. So this one isn't going to just plain old undo each other. Where is 100 degrees? Actually, not that far over. Sorry. It's just 10 degrees past 90, right? All right, I really didn't do that well at all. But it's not one of our, unit circle values. It's just a little bit past 90 degrees. But it doesn't really matter as long as you know what quadrant it's in. You're just going to use the reference angle of that. Okay, so this is 80 degrees. If it's 100 to here, it'd be 80 to there, right? So in the restricted quadrant, it would just be the reflection of it over here, so that's going to be 80 degrees. So same thing with this one. Inverse cos of 300. Well, is 300 in between negative 90 and 90? Clearly not. So think about where that angle is. 300 degrees is all the way over here. What's the reference angle of that? How many degrees are left to get all the way around? 60 degrees. So and the reason the reference angle works, since I don't like tricks, the reason it works, right, is because if you're talking about cosine and it's down here, cosine is just the x value, right? Our cosine restricted domain is here, so it has to be the positive cosine, so it's just going to be this reflection in this direction. The same cosine positive value has to be in the first quadrant at that same spot. So the reference angle is going to work there. All right. Why would they do this? Okay, inverse is not on the unit circle. So we're still going to restrict the domain the same way. Okay, but if we have values that aren't on the unit circle, we have to do the same thing we did with actually sine, cosine, and tangent that weren't on the unit circle. And that was, if you remember, Pythagorean theorem. Like we drew a triangle, and we used the values they gave us. We used Pythagorean theorem to find the missing side, and then you use SOHCAHTOA to figure out the sine, cosine, or tangent. Okay? Ready? All right. So this first one is broken down into the steps here for you. This is trying to like sort of explain how to do it. All right. So sure you're referring to down below this, okay? So what you're asking yourself is the tangent of what angle is 1/2? Well, there's nothing on the unit circle that has a tangent equal to 1/2. That just isn't on the unit circle. So we have to draw ourselves a triangle on the coordinate plane. So you have to think about, if you're a Circix type of person, you can think about it as y over x. If you're like me, you're thinking tangent is opposite over hypotenuse. I'm sorry, no it's not. It's opposite over adjacent. You would think I'd do this enough that I wouldn't make a mistake like that. OA, right, TOA, opposite over adjacent. And then we have to think about what quadrant we're in here. If it's a positive and our restricted domain for inverse is in either quadrants 1 or 4, and we have a positive tangent, which quadrant does it have to be in? 1. That's really important that you pick the right quadrant. All right? So there's only one answer to that question. If you have a tangent, an inverse tan, and it's positive, it can only be in the first quadrant, because sine over cosine or opposite over adjacent, whatever you think about, in this direction, that y value is negative, so it's going to turn your tangent negative, right? So if it's a positive tangent, it has to be quadrant 1. It has to be the first quadrant, because it's tangent and because it's positive. So far, you're good? Okay, so now we're going to draw a triangle and use SOHCAHTOA and the Pythagorean theorem. So when we're drawing our triangle, remember we're thinking opposite over adjacent, and it's 1 over 2, and we're in the first quadrant. So we're going to have a triangle in the first quadrant where the opposite side, which is the y, right, is 1, and the adjacent side, which is the x, is 2. So you're going to go over 2 and up 1. And there's our triangle. Now Pythagorean theorem. 1 squared plus 2 squared equals r squared. And r turns out to be the square root of 5. Now we're taking the sine of that angle. Do we know what the angle is? No. Do we care what the angle is? No. We just care what the sine of that angle is. And so it doesn't matter what the angle is. We know that r now is the square root of 5. And we're taking the sine, and sine is opposite over hypotenuse. In our triangle, opposite is 1, hypotenuse is root 5. And then you rationalize the denominator, and you end up with root 5 over 5. Okay. So let's try another one. So this box is just a reminder. Remember, you never actually need to know what this angle measure is. That's never a question. You're just figuring out the cosine of the inverse of the sine of that angle You don't care what the angle is. Not that you care what the cosine of the inverse of the sine of the angle is, but you do if you want the right answer. Yeah. Not that that's really going to be useful in your life, but on the test. Sorry, but that is probably the only correct answer. Or if you take calculus next year, this stuff's going to come back. In some people's lives, yes. In my life, yes. Engineering, maybe. Don't even know. But yeah, I'm sure it's, something really important somewhere. It's a really bad answer. But, okay. So, all right. So, again, doesn't it, like, it's just fun for your brain, though, isn't it? It's like a workout. It's like, thank you, right? It's, those of you who love working out, it's not really fun, but you like doing it. This is a workout for your brain. It helps your brain. Strengthening the muscle of your brain. All right, I have 6 minutes, and I got to get through this here. Okay, so again, order of operations, we're starting inside the parentheses. We're finding the inverse sine of negative 1/3. Again, not on the unit circle. We don't care what this angle measure is. We just have to figure out what triangle to draw so that we can find the cosine of it. So first question is going to be what quadrant, okay? Which quadrant? Now, it's inverse sine, so we got two choices. Quadrant what or quadrant what? 1 or 4, because sine is either 1 or 4. It's negative, and it's sine. So if our choices are either 1 or 4, in which quadrant is the sine negative? 4. So it has to be quadrant 4. That is a really important thing to realize, okay? So now you know you're drawing a triangle down here somewhere. The inverse sine of negative 1/3. Okay, so sine is opposite over hypotenuse. So the opposite is 1, hypotenuse is 3. 1/3, right? So the opposite is 1, hypotenuse is 3. Remember, it's the negative's going to go with that opposite, because you went down 1. Now we do Pythagorean theorem. Remember, we're solving for x now. We already have the radius. So x squared plus negative 1 squared equals 3 squared. X squared plus 1 equals 9. X squared equals 8. And x is 2 times the square root of 2, or the square root of 8, which is 2 root 2. So the x value is 2 root 2. The y value is negative 1, and the radius is 3. So will the cosine be positive or negative in that quadrant? Cosine positive or negative in quadrant 4? Positive. What is the cosine value? Well, cosine is adjacent over hypotenuse. We look at our, this became 2 root 2, right? We look at our triangle. Adjacent is 2 root 2. Over hypotenuse is 3. And that's your answer. I am.